Okay, let's start section 4.2, which is about adding, subtracting, and multiplying polynomials. And also, we're going to look at Pascal's triangle. Let's get started here, and we'll talk about some of the special product patterns. If you look on the screen right here, our first one is when we take, I have two binomials, okay, and they are the same. The only thing different is that there's a plus sign in one binomial and the minus sign in the other. Okay, so if you were to FOIL this out, you would end up with a squared minus b squared. Or you would end up with a squared and then minus ab plus ab and then minus b squared. So then the ab's cancel out. So that's what makes this one of our special product patterns. So if you look at the example right here, this x plus 3 times x minus 3 ends up being x squared minus 9. Okay, you take the first and the last. Because the outer and inner terms, right here, I'll get negative 3x plus 3x, they cancel each other out once again. So this works right here, and if you take a look at the solution, this x squared minus 9, we should know this as a special factor of difference of two squares. And you should look that up if you're uncertain with it, but pretty much they're saying this. If you could take the square root of the a term, which is the x squared, and the square root of the b term, which is 9, okay, and there's a minus sign in between the two, then you just split it up. The square root of x squared is x, the square root of 9 is 3, and guess what? That's how it turned into x squared, or x plus 3, times x minus 3. So difference of two squares. That's if we were to go from our binomial into two factors. Next up, we have a square of a binomial. Well, actually, before we move on, remember, this is a difference of two squares. It only works when it's x squared minus 9. If I had x squared plus 9, this right here does not equal x plus 3 and x minus 3. And that's where students oftentimes make their mistake and think that they're both the same, and they try to do the same thing by taking the square root of the a term, which is x squared, and the b term of 9, and separating it apart. So that is a no-no. Now let's go to square of a binomial. Now right here, pretty much you have a plus b quantity squared. And so they're saying that this ends up being a squared, so whatever the a value is, you square it, plus 2 times whatever a times b is, and then plus b squared. So we have a special pattern. However, if you don't know the pattern, why not just write out the binomial twice and FOIL it? Okay, that's always a very simple solution to not getting this problem wrong, in case you forget. Because I do see a lot of students right here, they forget this all the time. And I've mentioned it so many times this year already. And what I oftentimes see is a student will write a squared plus b squared. No, that is not it. So write out the two binomials and then go ahead and FOIL it together. So if we look at the example that's given here, we'll take the a term, which is y, we'll square it. So that's where the y squared comes in. To get the middle term, it's going to be a times b, so 4 times y, which is 4y, and then you multiply it by 2, and that's how they come up with the 8y. And then finally, you take the 4, which is the b term, you square it, and then you'll end up with 16. And that's how it all comes together. You got to be careful, though, when there's a coefficient in front, because remember, you got to actually square that as well. So if you take a look right here at the second example, when we have the subtraction, now when there's a difference in our binomial right here, notice the middle term happens to be minus 2ab. Okay, It's important that the middle term be minus when we have a difference in our square of a binomial. So let's roll through this again. You take 2t, and then you're going to square that. So it's 2t times 2t. That right there is 4t squared. Next up, we take the two terms together. 2t times 5. That gets me 10t. Multiply that by 2, we get negative 20t. All right? And then finally, we got ourselves 5 to the second power. And then you get 25, and there's your square of a binomial. And our special pattern right here. All right, next up, with the cube of a binomial, there is another pattern. You can see what ends up happening right here. And the pattern in the cube of a binomial actually goes alongside with what we actually have been doing with what we'll take a look at in Pascal's triangle. You can, once again, look at the pattern and realize, okay, you take this time a to the third plus 3 times a squared times b plus 3 times a times b squared plus b to the third. And what I want you to notice here is this, that take a look at the a term. It descends. It starts with the highest power in the first term. In the second term, it's now 1 less, and that's why we have a squared. In the third term, it's another degree less, so it's a to the first. And then in the last term, it's actually b to, or a to the 0 power. It goes from 3, 2, 1, 0. And a to the 0 power ends up equaling 1, so we don't need to actually write that down. Take a look at the b term, okay? The b term ascends. It starts right here in the first term. It's actually b to the 0 power. The second one goes from b to the first. The third, we have b to the second. And the last one, you have now b to the third. So you got to remember this. The a value, or the first term, descends. It goes from high to low. The second term goes from low to high and ascends and goes from 0 up to whatever the highest power is. And so we'll take a look more of this when we do some of that Pascal's triangle, which, guess what, is coming up next. So in Pascal's triangle, there is a pattern here. Should you remember the pattern? You can, but it's pretty, I mean, you don't need to memorize it because you could actually figure it out along the way. But here's one thing I do need you to remember in Pascal's triangle. The very first term and the very last term is always going to have 1 as the coefficient. Okay, so what we're looking at right here, all these numbers, the 1s, the 2, 3, 4, 6, all that stuff, those are the coefficients of each and every term. Okay, so once again, take a look at this. When we have right here a plus b to the 0 power, something, a binomial or whatever, a term to the 0 power ends up equaling 1. So therefore, we have 1 as our binomial expansion. In row 1, when my exponent is to the first power, then that will be a to the first and b to the first. And once again, take a look right here. We actually have 1 and 1. That will be the coefficients. And you can see right here, 1 and 1 in the Pascal's triangle. Second row, if we have to the second power, a plus b to the second power, or the first term will always be 1 in this Pascal's triangle, or when we're dealing with binomials. Okay, so you can see the 1 right there, the 1 as the last one as well. The middle term happens to be 2. And we talked about the pattern, how it's 2ab. So there's your middle term. So there's also another pattern that you may see. Because when you use Pascal's triangle right here, how do they get the next term? Well, it's connecting the 1 and 2, add them together, and you get 3. The 2 plus 1 gets me 3. And then you can figure out what the middle terms are, or the next term. Okay? So now that we kind of have that, I also want to show you what else is happening here. If I want to get my middle term, there's a pattern. And the pattern I'll show you right here. Actually, let's go down to the 6th row. Okay? So, and I guess let's go down one by one. So right here, remember, we start off with 1 as the coefficient, and then it becomes a to the 3rd power. So whatever the a value is, we raise that to the 3rd power. And then, remember what I told you. The a value will descend in each and every term. It's a to the 3rd, a to the 2nd, a to the 1st, a to the 0. And then remember, the b value will ascend, and it'll go up. Right here we have b to the 0, which we don't need, but then we go b to the 1st, b to the 2nd, b to the 3rd. And the 3rd power will be the highest because of our exponent. Now another thing to take note, because there's so many more things here. If you take a look at the pattern, how many terms do we have in each row? Well, whatever the exponent is, you will have one more term, or add 1 to that number, and that will tell you how many terms we have. So right here, in row 1, it's to the 1st power. So let's add 1 to it, and that'll tell me that I have 2 terms. And guess what? You see 2 terms here. If I look at row 4, okay, that's to the 4th power. If I add 1, that's 5, so that means I should have 5 terms. And guess what? You see 5 terms right here. Perfect. So once again, taking a look at row 4, we start off with 1 because that is how the Pascal's triangle works. The first term will always be, coefficient will be 1. And so will the last. Alright, so that one should be pretty easy. How do we find the next one? Well, how do they get this 4? Let me show you how. Let's go ahead right here. To get this 4, we're going to take the exponent, the highest power, and we're going to divide it by 1. And then that's how we get 4. Just that simple. Remember, now with Pascal's triangle, it's always going to be equal. If you look at it, everything looks symmetric. So if I have 4 on one side, I better have 4 on the other missing or opposite side on the term. Now how do I get the 6? This is the trick right here. If you draw a Pascal's triangle, that's great. But if they ask you to find, like, expand this to like the 100th power, I don't think you're going to want to draw a triangle that's going to go all the way down to 100. So the next part here is this. It's real simple. How do we get the 6? I'll put it right here. And you guys should probably have something on a separate sheet of paper where there's more space. I'm just finding a gap right here. We take 4 and multiply it by 1 less, which is 3. For my denominator, I take 1 and I multiply it by 1 more, which is 2. So then I end up with 12 over 2, which equals 6. And guess what? There's that number right there. And that is your middle term. And that keeps working over and over and over again. So let's put everything together in row number 6. Okay, so let's say we have the 6th row. And what we have right here is a plus b to the 6th power. I always start off right here by realizing, okay, let's mark how many different terms we should have. So if I have my exponent is to the 6th power, I should have a total of 7 terms. So 1, 2, 3, 4, 5, 6, 7. The first and last term is easy, always 1 and 1. The second term is also easy because it's going to be whatever the exponent is. So I have 6 on one side, 6 on the other. Alright, pretty easy, pretty straightforward. So what do I do for the next one? Okay, well, once again, what did I do right here to get this next term? What I showed you before was I took 6 and I put it over 1. So for my next term, what I'm going to do right here is take 6 times 5 and divide it by 1 times 2. 6 times 5 is 30, divided by 2, we get 15. If I have 15 right here, I have a spot on the other side for it, 15. Now, how do I get my next term? Well, I'll continue on and I'll take 6 times 5 times 4. We are descending, and I will ascend right here and put 1 times 2 times 3. Alright, so the numerator descends, the denominator ascends. So 5 times 3 is 30, 30 times 4 is 120. So I got 120 divided by 6. And that'll end up being 20. Alright. And there you have it. Are we done yet? Not quite. So now, we have to figure out, now that we figured out the coefficients, those are all the numbers that are in front. We've got to figure out what goes next with our terms. Well, to start off with, remember, we will start off with the highest power, and we'll start off with a, since that's our first term. So I have a to the 6th. Remember, we descend with the first term, we will ascend with the second one. And I'll just go ahead and put b right there to the 0 power. So there's term 1. Let's go ahead next up. Okay, we've got 6 as our coefficient. So I'm going to include 6. And we're going to multiply that by a. It's going to descend, so it's to the 5th power. And then we have b to the 1st. Let's go to the next one. Our coefficient is 15. And then we will descend. It's going to be a to the 4th. And then we have b to the 2nd. In our next term, we've got 20 as the coefficient. We'll have a to the 3rd, b to the 3rd. For the next term, we have 15. Multiply that by a to the 2nd, b to the 4th. Then we have our next term, 6 times a to the 1st, b to the 5th. And then finally, we have ourselves coefficient of 1, and then we've got ourselves a to the 0, b to the 6th. So we put it all together in the end. My final answer, now remember, we have a plus sign, so everything is going to be plus. If we have the difference, then what ends up happening is we start alternating signs in between. Okay, and that's the trick right there. So let's go ahead. I'll put my answer. We have a to the 6th plus 6a to the 5th b plus 15a to the 4th b squared plus 20a to the 3rd b to the 3rd plus 15a squared b to the 4th plus 6a b to the 5th, and then plus b to the 6th power. And it's beautiful. We got this nice answer using Pascal's triangle. So you will notice that there are some problems you'll do tonight for homework that will involve Pascal's triangle. And so hopefully when you practice it tonight, do your best to follow exactly what I was able to do here in this to find the 6th row. So let's move on to some example problems. So a little bit long section because of this Pascal's triangle. Takes a little bit more work. Let's start off with number 1. Let's find the sum and the difference. Remember, sum right here is we're adding things up, and we've got to add like terms. So I got negative 4x squared plus negative x squared. That is negative 5x squared. I take a look next up. I've got negative 6x plus a positive 7x. Negative 6 plus 7. Last I remembered, that is positive x. And then finally, for the last part right here, I've got 18 plus 8, and that's going to get me a positive 26. We have simplified this. Adding is usually not the problem. It's when we subtract, like in number 2. And I always tell my students, hey, make sure. The easiest thing is when we subtract, we've got to change the signs, or remember, you're adding the opposite. So I'll change this to plus sign in between. I'll change the signs inside of the binomial right here, and that will usually help lead us to the correct answer. Because now, let me combine our like terms. 6x squared plus x squared, 7x squared. We have next up, negative 12x plus a negative 24. That's going to be a bigger negative number, which is negative 36x. And then we have 48 plus 63. And that will get us plus 107. All right, or actually, that will get us plus 111. And we have now simplified by adding these binomials together, or polynomials actually. Okay, next up, let's find the product. I think number 4 should be pretty straightforward. Don't forget, there is a rule when you multiply powers. Hopefully you know it. You're supposed to add the exponents. So 2x squared times 2x to the third. That gets me 4x to the 5th power. Okay. Remember, the rule here is when you're multiplying exponents, you add the powers together. Sorry. I know this is another one of those things where a lot of times students end up multiplying the 2 and they say 2x to the 6th. Not it. Next up, we take 2x squared, we multiply that by negative x squared. So that gets us negative 2x to the 4th. Then we multiply it by 3x, and we'll end up with plus 6x to the 3rd. Multiply it again by negative 5, and we get negative 10x squared. Make sure if you have to, you rewrite your answer in descending form. You don't really have to do that here because it's already put together in descending form, and we are golden. Next up, number 5. So when we deal with two trinomials right here, you're doing exactly like what you did before. You are foiling, but you also must be careful. Make sure that each and every term gets multiplied. So what I tend to do is, hey, use different colored pens or draw lines, I don't know, squares, cubes, rectangles, whatever you may have learned in elementary school. And we got x to the 4th times 3x squared. That gets me x 3x to the 6th. X to the 4th times negative 6x is going to be negative 6x to the 5th. And then for our x to the 4th times negative 1 is going to be negative x to the 4th. Okay, next up, then let's take the negative 10x squared, and we are going to have to multiply it 3 times. So now, negative 10x squared times 3x, negative 30x to the 4th. The next one we have right here, positive 60x to the 3rd, and then we have plus 10x squared. We're not done. We have to take this 25, and we pretty much do the same thing again. We repeat. And so we have 25 times 3x squared. We got positive 75x squared. We have 25 times negative 6. That ends up becoming negative 150x. And then 25 times negative 1, negative 25. Last thing you do is put it in descending order. Simplify, combine like terms as well. But put it in descending order. Your actual answer right here looks like it should be 3x to the 6th, and then we have minus 6x to the 5th, minus 300 and actually 31 x to the 4th, plus 60x to the 3rd, plus 85x squared, minus 150x, minus 25. That is what you have in descending order. All right, moving along. Okay. Taking a look at number 6. What I would do in a problem like this is begin by foiling the first two terms. Okay, so you have to take it piece by piece at a time. So we'll FOIL this out. X times x is x squared. The outer is minus 2x. The inner is plus x. And the last is minus 2. So I got x squared minus x minus 2 right here. And then we have to multiply that by our binomial of x plus 6. Multiply that out, just kind of what we did right there on number 5. And if you do that correctly and well, let me just get to the final answer. We have x to the 3rd plus 5x minus 8x. I believe it should be minus 12. All right? And there is your final answer. Remember, how do you get there? You must take this right here and pretty much distribute it out, just like what we did on number 5. Okay? Draw lines, make sure that, hey, each and every term gets solved correctly. All right. So let's get to the nitty-gritty of using Pascal's triangle doing number 10 and 11. Once again, space will probably be an issue. So what I'm going to go ahead and do the problem right here. Let's start off. Remember, in order to expand this, look, you could take 4 plus 4t minus 2 times 4t minus 2 times 4t minus 2 times 4t minus 2. But it's not a whole lot of fun. A lot of mistakes can happen. I guess either way it's pretty challenging. But remember, if my exponent is to the 4th power, that tells me I should have 5 terms. The first and last term is always the same. It's going to be 1. The second term right here will be the exponent itself. So 4 and 4. Remember, this middle term, what we do is we descend. 4 times 3, numerator, we ascend 1 times 2. So I got 12 over 2, which is 6. And so these numbers right here, once again, are the coefficients. It's not the entire answer to when we expand this out. So, what do we do next? Okay, let's take the first term. It's going to be, well, we have our coefficient, which is 1. And then, right here, I want to take my first term, which is 4t, and we raise that to the 4th power. We take the second term, which is negative 2, and we raise that to the 0 power, which will end us up with 1. So we don't really need to worry about that right there, and we'll leave that as is. So when I simplify this down right here, we got ourselves our first term, which is 4t to the 4th. Now there's a little more challenge involved. We go to the second term. We have the coefficient, which is 4. I will now take the 4t, which is the a term, and raise that to the 3rd power. Let's take the second term, the b term, negative 2, and then that goes to the 1st power. Remember, it goes descending to ascending. Or right here, we got negative 2 to the 0. I can show you how it ascends. Now we're going to simplify this. So we have right here, 4t to the 3rd. All right, fun times right there. It looks like that is 4 to the 3rd, 64. And then I got to multiply that by 4. We get ourselves 256. And then I have this negative 2 right here. And so that'll get us negative 512. T to the 3rd. There's your second term. Okay, so once again, order of operations is key. 4t to the third power, you got to do that first, and that'll get you your 64t to the third. Multiply it by 4, that gets us your 256, and then multiply it by -2 to get -512. Let's go do the next one. Right here, let's take our coefficient now is 6. We stay with 4t. That is going to be to the second power. Remember, it's going to descend right there. And then we'll take the b term, and that'll ascend, and that'll be to the second power. So once again, we use our order of operations. 4t squared, that's going to get me 16t squared. 16 times 16, or sorry, 16 times 6, 96. We're going to multiply that by -2 squared, which is 4, and we end up with positive 384. So plus 384, remember right here we ended up with t squared. We got this. We got our middle term now. Next up, coefficient of 4. We'll take the a term, 4t. We'll raise that to the first power, descending. We'll take the -2. We'll raise that to the third power, ascending. So 4t to the first is 4t, times 4 is 16. And then we got -2 to the third. That is right there, -8. So -8 times 16 gets us a wonderful -128. So we got -128t. And then let's finish this off right here. We've got our coefficient of 1. I've got 4t to the 0 power. We've got -2 to the 4th. 4t to the 0 power is 1. 1 times 1 is 1. We've got -2 to the 4th power, and that's going to get us a positive 16. And this right here, guys, is our final answer. No need for foiling 4 times. Just go ahead, put it together, and we solve it out. All right. So remember, I try to color code things to help you remember that it's the same parts, A and B. You're descending with one, the A term. You're ascending with the B term. You just got to be careful when you put it all together to be able to get your answer. But I know you can do it. All right. So there, right here is section 4.2.